Hey everyone, welcome to this video on scalars and vectors. Have you ever wondered why speed and velocity aren't the same thing, or why force has both a size and a direction? Today we're going to explore the difference between scalar and vector quantities in a simple and engaging way. First up, let's talk about what physical quantities are. In physics, we measure different quantities like distance, time, speed, and force. But do all these quantities behave the same way? The answer is no. That's why we classify them into scalars and vectors. So what are scalar quantities? Scalar quantities are those that only have a magnitude or size and a unit. They don't need a direction. Some common examples include length. A person's height is 165 centimeters. Mass an object weighs 50 kilograms. Temperature. The weather today is 30 degrees Celsius. Time. You waited 60 seconds for the bus. These values are complete as they are, no direction needed. Now what about vector quantities? Unlike scalars, vector quantities require both magnitude and direction. Some examples are velocity. If you're driving at 40 kilometers per h east, both the speed, 40 kilometers per h, and the direction east matter. Force. If you push a box with 50 newtons upwards, the force's direction determines its effect. Displacement. If you move 30 kilometers north, it's different from moving 30 kilometers south. Direction is crucial. Let's look at some real-life examples. Imagine you're running on a circular track at 10 mph. This is your speed, a scalar. But if we want to describe your velocity, a vector, we must also specify the direction you're moving in at each moment. So why does this matter? Understanding scalars and vectors is essential in physics and everyday life. For example, engineers need vectors to design bridges and buildings. Pilots use vectors to navigate flights. Athletes use vectors to analyze movement and performance. Now you know the key difference between scalars and vectors. Scalars only need magnitude, while vectors need both magnitude and direction. If you found this video helpful, don't forget to like, subscribe, and share for more fun physics explanations.